So I've got another one of the extended response questions here. We've got Edge Races developing a program to process information on races with multiple stages, and there's a little diagram here of different stages of a race. It says that the first race has 4 stages, so it's showing us that each stage, the distance in kilometres. Design for part of the program is shown below, so it's going to loop 4 times, so for each stage, and get a valid distance. Now the important bit here is the word valid, because that should be cluing us in that we're going to do some input validation. Then it says using a design technique of your choice, and I've been encouraging my class to do pseudocode because you're far more likely, in my opinion, to mess it up if you try and do a structure diagram or a flowchart. Using a design technique of your choice, refine step 6.2, so just the getting the valid distance, not the loop, to check the user enters a valid distance. So what is a valid distance? Well, a valid distance is 5 to 75 kilometres, so it's got to be between 5 and 75. So you need to know the steps for an input validation algorithm. There's 4 marks here. It's quite a kind of common input validation question. There's nothing fancy about it, like we're not using a length function or we're not rounding something. So it's just a straightforward input validation where we're going to ask the user to enter something, and then if it doesn't meet the criteria, use a conditional loop to keep looping round until they enter one that is valid. So first thing I'm going to do is get them to enter a distance. So if I said there, enter distance, or ask user for distance, or something like that, because it's just pseudocode. Then, while the distance is less than 5, or the distance is greater than 75. Now, I'm using an or in there because if it was an and, that wouldn't work, that wouldn't make sense. The distance couldn't possibly be less than 5 and greater than 75 at the same time, because there's no number that would meet that criteria. So this is why it's an or. Then inside the loop, we would show an error message and ask the user to re-enter the distance. And then I might just end my conditional loop there. So that's my straightforward input validation algorithm. So then I've got a test data question. It says test data is used to ensure the distance entered is valid. So that's the 5 to 75 that we had in the previous part. State the type of test in the table below. So we've got normal, extreme and exceptional test data. So 67.6, that's within the range and the program would continue. So that's normal test data. 3.7, that's outside the range. So that's exceptional. In this case, there isn't an extreme one. If it was extreme, it would be bang on 5 or 75. We've got a couple of lines of code here written to input the distance for each stage. Changes are going to be made to ensure that any number of stages can be processed. So instead of 0 to 3, it's going to be any stage or any number of stages. So describe 2 changes that would be required. Well, first of all, you would have to ask the user to enter how many stages. So we'll say enter number of stages, and you would store that in a variable. Then once you've got that, you would replace the 3 and you would use the variable. In the loop. Instead of 3. Now we've got a part where Edge Races classify races as beginner or intermediate or advanced based on the total distance of the race. The program displays the classification after calculating the total distance. So it's already doing this line 25, calculating the total distance. We don't need to care about how that works. Then we've got a bunch of if statements. So if the total distance is less than 25, it will set the race to beginner. So if, for example, it's 10, it would set it to beginner. If it's greater than or equal to 25, or it's less than 100, then it would set it to intermediate. And if it's greater than 100, then it would set it to advanced. So when tested, it produces an unexpected result. Identify the type of error. Now, there are 3 types of error. There are execution errors, syntax errors, and logic errors. Syntax errors are where you've got some sort of spelling mistake, grammatical mistake, essentially, in the programming language, and that's not the case here. An execution error is when your program is going to crash. That's not really the case here, but if we look at what the logic error is, if it's less than 25, so say I've got 10, then that would be beginner. Then we've got if the total distance is greater than or equal to 25, so 10 isn't, or the total distance is less than 100, but 10 is less than that as well. So then it would suddenly change from beginner to intermediate with the same value with the 10, because it would meet this updated or more recent criteria. And then if the total distance is greater than 100, then that wouldn't apply if my value is 10. So it's a logic error. So all I have to do there is identify the type of error. I'm not being asked to describe what it is, but I thought it was helpful, rather than me just saying the word logic, to show you what the error actually is. So it's this bit. The code is inefficient, so using a programming language of your choice, rewrite lines 26 to 34 to make it more efficient. So 26 to 34, it's these if statements. Now this is one of the fewer programming language questions in this paper. You'll find that varies from year to year. Some questions will be a design technique, some will be a programming language. I'm going to write this in Python, because that's the programming language that I use, and it's what probably about half of the skills use. And you've got to write in a programming language. If you don't remember exact code to do something in a programming language, you're not going to get marks for like just doing a diagram anyway. That's not going to get you some sort of half marks or something, like sometimes people try to answer. It's a programming language or nothing. So you've got to attempt this in a programming language. So lines 26 to 34, to make them more efficient, what I could say is, we'll keep the first bit. If the total distance is less than 25, so if total distance is less than 25, then race equals beginner. Now we're going speech marks. Now I might run out of space here just when I'm doing it with the stylus, so I might not put the set race part in every one of these if statements. Instead of having a separate if, I'd have elif. If your programming language is VB rather than Python, then it would be else if, but it's going to do the same job. So elif, the total distance is less than or equal to 100. Race equals intermediate. And then I don't need a condition for the last one, because if it's not less than 25 and it's not less than or equal to 100, then it must be greater than 100. So I don't need the condition again. Else the race equals, okay, what it is, advanced. You can see that I've sort of eliminated this condition here, because I don't need to check if it's less than 25. If it was, it would have triggered the first condition, but because I've used an else if, it's only ever going to do one of them. So if that first condition was met, then it's not going to check whether it's less than or equal to 100. It would just skip straight to the end of the if statement. I've also missed a colon in there. There we go. During execution, this code is translated. State the type of translator that's been used. I thought this was maybe quite a tricky question. You'll often get something about what type of translator. The key point here is during execution is when it's translated. So the program is translated as it's running, so therefore it's an interpreter. If it had been translated before it was running, then it would have been a compiler. And I've got the last part of question 11. We've got a variable called average distance, or AVG distance. Now this is written in a different font. It's kind of indicating to us that this is code. We're going to be expected to use that variable name. So when they've done this, they've given you the name of a variable and they've put it in your new monospace type font to look like code. Then you're going to have to use that variable name. Using a programming language of your choice, so again I'm doing Python, write the code to store average to 1 decimal place. So we have 3 predefined functions in National 5. We've got length, random, and round. This is not a random number. It's not the length of something, although it's 1 decimal place, because that's to do with how many letters are in a string. So I'm going to use a round function. So in Python, and it's going to look similar in most programming languages, if I said avg distance equals round avg distance 1. So that's going to round it to 1 decimal place. Something that sometimes confuses people, you can have the same variable name here and here. So you're just rounding itself and putting it back into the variable. And now that value on the left hand side, avg distance, if you use that in another line of code, that's been updated, that's changed. Then it says that the average stage distance should be displayed as shown below for race 1. Using the programming language and the variable avg distance, write the code to produce the output above. So really, if you're doing this in Python, for example, you're just writing a print statement that's going to produce that output. You're not including 20.4, you're using the variable. So I'm not going to say print the average is 20.4, I'm going to say print the average is average distance. So if I said print, then speech mark, because this is a literal string, the average is, but instead of 20.4, I'll put comma avg distance, because that's a variable. Then another comma, because we need km for kilometres, which might be the part that people would miss, and closing my bracket. So I've got 2 literal strings in there, and I've got the variable name avg distance. So instead of saying literally avg distance on the screen, it will say whatever value is in there, which will be the value that we've just rounded it in that part above.